Section 5.1 is about fundamental trig identities. So I've put up on the board here the definition of an identity. An identity is an equation that's always true if both sides are defined. Okay. And I'm going to just give us a couple of examples. So I'm going to list some identities, and then if we've got an equation that's not an identity, it's what we would call a conditional equation. I'm going to actually start with some that have nothing to do with trig, and then we'll move on to some trig identities and some trig conditional equations. Okay. If I have 2 times x plus 1 equals 2x plus 2, that's an example of an identity. That's actually always true because both sides are always going to be defined. This is just essentially an example of the distributive law. Okay. If I distributed the 2, I would get 2x plus 2. And since the distributive law is always true, this is an identity. It's always true. Okay. That's different from something like 2 times x plus 1 equals 4. This is what we call a conditional equation. This would be true if x is 1 on the condition that x is 1, because then this would become 2 times 2, which would be 4. If that condition that x is 1 is not satisfied, then this is false. Conditional equations we're generally going to be asked to solve. Okay, so we would be figuring out what value of x makes that true. If you were asked to solve this, because it's an identity, what you would get is that your solution set is all real numbers. And generally with trig identities, we won't be solving them, we'll be proving that they are true. And what they do is they give us an option for how we're going to write things. Sometimes it's easier in algebra to have things factored. Sometimes it's easier to have things multiplied out. This identity gives me the option of writing this expression either way. And in trig, those options are often going to be very helpful. They're going to make different expressions easier to work with if we write them in different ways. Okay. Another example, something like x over x equals 1. Okay. Like to include this example because that's not always true. If x is 0, the left side is undefined. We still say this is an identity because I didn't stop here and say an identity is an equation that's always true. I kept going and said if both sides are defined. Okay. So that's a really important caveat that both sides have to be defined in order for it to be true. Let's take a look now at some trig equations that are identities versus conditional equations. An example of an identity would be something like cotangent of x is the reciprocal of tangent of x. Now this is an important one to remember, that this is true if both sides are defined. This is not the definition of cotangent, because cotangent is 0 at certain places, and those happen to be the places where tangent is undefined. If I were to look on the unit circle, since cotangent is capital X over capital Y, that's going to be 0 at these two places where the capital X value is 0. That would be at odd multiples of pi over 2. Well, at odd multiples of pi over 2, the left side of the equation is defined, it's 0. The right side is undefined because tangent is undefined and you can't take the reciprocal of undefined. So again, this caveat is that an identity is something that's always true if both sides are defined is very important. But if tangent and cotangent are both defined, they are reciprocals of each other. And so that would be an example of an identity. And the value of that is that sometimes this might be simpler, just having one trig function rather than having the reciprocal of a trig function. But in other times, this might actually be easier to work with. If I'm evaluating this at a particular angle, I'm more familiar with tangent than with cotangent. So I'll often evaluate the tangent and then flip it to get to the cotangent. So depending on what I'm doing, this version might be easier to work with or this version might be easier to work with. And the identity just gives me the option of writing things either way. A conditional equation might be something like this. Sine of x is equal to 1/2. Okay. Now, that's sometimes true, but it's only true for certain values of x. Okay. At the end of this chapter, we're going to be solving conditional trig equations. I will just point out right now, this equation has infinitely many solutions because this is a positive number. sign is positive in quadrants 1 and 2, so I'm going to find a solution in quadrant 1, I'm going to find another solution in quadrant 2, but once I have those solutions, anything coterminal with them is also going to be a solution. So when we get to solving these at the end of the chapter, almost always when you're solving a trig equation, you're going to be getting infinitely many solutions. Okay, so we'll just keep that in mind. We'll get there eventually.